Hello, hello! We are working on section 5.1, page 2. About halfway down the page, there's a warning. So we're going to start with that warning that tells us that the critical points, which are just the stationary and singular points, are points that belong to the domain of our original function. So when we're looking for our singular points, we're looking for values where the point is not in the domain of the derivative, but it is in the domain of the original function. So f prime of a does not exist, but f of a does exist. Okay, so let's do an example that'll show that. We have f of x being 1 over x, and once again, we're asked to find the stationary and the singular points. For the stationary points, we're going to repeat again and again and again that the stationary points are where the derivative is 0, and the singular points are where the derivative does not exist. To answer both of those, we want to take the derivative, but first let's take a little sidestep and talk about the domain. So the domain of our original function, we can't plug in 0 for x because that would make the denominator 0. So we can plug in any number we want except for 0. Okay, so our domain of our function is everything except for 0. Let's get to our derivative. So we have to first rewrite our original function to be x to the negative 1 power so that we can use the power rule. We're going to multiply that negative 1 to the front and then subtract 1 from the exponent. So we get negative 1 x to the negative 2 power, which is negative 1, and that x squared gets dropped down. All right, now we want to split up and find our stationary point, which is where the derivative is equal to 0. If a fraction equals 0, its numerator is what's equal to 0. So let's set negative 1 equal to 0. Hey, that's not true. We have negative 1, which is a constant, equal to 0. That's never going to be possible. So we have no stationary points. On the other hand, let's find our singular point, which is where our derivative does not exist. If we have a fraction, the only place it's not going to exist is when the denominator is equal to 0. So let's set the denominator equal to 0. That's x squared equal to 0. To solve for x, we're going to use that square root property. So x is equal to the square root, plus or minus, cannot forget the plus or minus, is equal to 0, which in both cases it's 0 anyways. But hey, let's remember the domain of f of x said we could plug in anything except for 0. So this 0, it's true, it's not part of the derivatives domain, but it's also not even part of the original function's domain. So that's not included in the original domain. We can't include it here, so there's no singular points. Let's just say that we were doing the problem and we weren't really worried about the domain, so we didn't catch this. The next point would be to find the y value because we need to answer in coordinates. We have the x value, x is 0, and to find the y value, we would plug it into our original function. So we would plug in 0 to 1 over x, which would be 1 over 0. And hey, that's undefined. So even if we weren't paying attention to the domain, we would really find this out just a different way. All right, so if we go back and summarize our work, we have that there's no stationary points and there's no singular points.